All right, thank you all so much for coming. So my talk's title changed a little bit, and if any of you were at the keynote earlier, you guys know that we've introduced some awesome new functionality with objects. So now it's designing AR apps for the real world, environments, and objects. Well, good morning. I've been looking for an excuse to use that GIF/GIF, depending on religion. All right, so by a show of hands, how many developers we got in the crowd? Awesome, awesome, awesome. That's what I like to hear. Okay, so this is the obligatory introduction slide to Vuforia. We make an awesome AR SDK for developers, specializing in advanced computer vision that tracks objects and environments and allows you to put your content into the real world. Now, by a show of hands, how many of you guys here have used Vuforia in the past? That's right, yeah. Yep. So that's not unexpected. Vuforia is the leading AR platform. So many of you who have used Vuforia, you guys have been making awesome, amazing AR experiences. And these experiences have been built tracking objects, images, text, and view marks. And we're going to continue making amazing experiences using this technology, these trackables. But at Vuforia, we're always pushing the envelope. We're looking to find ways to make augmented reality experiences even better. And specifically, we're looking to figure out ways to make development in AR better for developers. So recently, very recently, we've introduced two new pieces of functionality that I think a lot of you guys will be interested in. One of these is model targets, and the other one is advanced smart terrain. So for those of you who were at the keynote, you guys know we introduced model targets today. This is hot off the presses. And what that allows you to do, it allows you to track 3D meshes and CAD models in the real world. So we can track large objects such as cars, machineries, and small objects like toys. And what's really cool about this is that it tracks based on geometry. So we don't need any fiduciary markers. We can just track based on geometry. So the color or little details about what you're tracking matters less. So if something gets worn or rusted or a little bit dirty, we'll still be able to track it really accurately. Quick little video here showing some of the awesomeness of model targets. We'll go into a little bit more detail later on. So smart terrain. So smart terrain we announced earlier this month at Vision Summit, and this allows your AR content to explore the real world and sort of get out of these trackables and be exposed to the real world. And a quick little video of smart terrain in action. So a lot of the awesome and amazing AR experiences that we've seen today have been around gaming and around toys. We're going to continue working and improving the developer experience in this area. But in addition to that, we want to see more AR experiences in shopping. So with model targets, existing consumer goods can be augmented, and we hope to see a lot of awesome things built on that. In addition, with stuff like smart terrain, we can better accurately place virtual content in people's homes, offices, and workplaces. Now, as far as workplaces go, I think there's a ton of opportunity with both model targets and smart terrain, right? So we can better put contextually sensitive procedural information for workers. So, we want to see the next generation laboratories, we want to see the next generation plants and construction machines and whatnot. So we're really looking to the developers to help us, sort of create this augmented reality future. Now, let's talk about some challenges in designing for AR. So at Vuforia, we think a ton about what it takes to make AR content and AR experiences. And we've sort of categorized, we've sort of mapped out 4 areas where we see a lot of the challenges that developers face. And one of these is hardware, and I'll go into a lot of detail on this. Actually, let me back up here. So we have hardware and algorithms on the machine side, and then on the human side, we have usability and workflow. And we'll dig into these a little bit. Okay? Now, so optical cameras is sort of the main driver for a lot of our augmented reality content today. And particularly, we use a lot of RGB cameras. Some devices will see black and white wide-angle lenses. Inertial sensors also play a huge role, and that is the gyros and accelerometers that allow us to detect motion, detect rotation, and whatnot. And with some awesome new devices, we're seeing a lot more infrared or depth sensors, in particular in some devices, and that makes for some awesome augmented reality experiences. Now, the data from each of these sensors on their own provides a lot of useful information. But through a technique called sensor fusion, we sort of tie these together and they complement each other. And the data that we get from sensor fusion is greater than any individual piece of data. And as a result, we have every year we're improving our experiences. Now, a lot of what we've seen today have all been using just inertial sensors and optical cameras, right? So that's your standard smartphone that you have in your pocket. Now, some of our partners, so Google and Microsoft, have been working on amazing technology that gives us this additional this additional piece of data, which is in depth. So Tango and HoloLens in particular. And today we have 3-ish devices available for consumers. The Fab 2 Pro, which is currently available, the Zenfone AR, which hopefully will be available soon, and then of course the HoloLens. And Fab 2 Pro and Zenfone powered by Google Tango, and HoloLens is powered by Windows Mixed Reality. So that's the hardware, right? So those are the sensors, those are the devices that is sensing the world around us, providing us critical raw data that we then use as inputs into algorithms. And these algorithms is what Vuforia is providing for developers. These really advanced computer vision algorithms that makes developing for AR so much easier. So we take this input, this raw data, we process it in algorithms, and then we can place our objects in the real world. And that's the machine factors. Now, for usability is particularly tricky when it comes to augmented reality because, I mean, not only do you have the situation where you don't know what the user's going to do, you don't know where the user's going to be, right? So you have to compensate for that. In workflow in this case here is sort of two parts because we have two sets of challenges when it comes to workflow. The first set of challenges is what we need to do as developers to produce amazing AR content, right? So in the case where we want to augment some kind of some technical machinery or whatnot, we need to convert the CAD model into something that we can use. Or in the case where we want to run on a low-end phone, right, we might have some virtual content, some 3D content that we need to make sure that it's optimized to run properly on mobile. So those are the two sort of areas for workflow. Now, the environment plays a critical role, and it always has played a critical role when it comes to AR, because that's what we want to augment, right? That's the area where we play. But when we're talking about, when we make the environment itself the subject of what we want to augment, it becomes even more critical for us to be concerned about it. So like I said before, we think a lot about the challenges that developers face, and we're trying to think of ways to communicate the constraints that we're under, or the constraints that we want to make sure that we're within to provide an optimal augmented reality experience for the end user. So right now we have 3 different models, right? We have illumination, we have range, and we have feature density. So illumination is the easiest one to explain because I think that's the one that we're most familiar with. Anybody who's ever used a phone or a camera to take a photo, we know that if we're trying to take a photo of an image that's too dark, we're going to get a lot of shadows, right? We're going to lose a lot of that rich detail of the environment or the object due to the fact that we don't have enough light. Likewise, if any of you have used a flash that's too bright or an ISO setting that's incorrect for outdoor area, you know that you're going to get way too much light. You're going to get way too many highlights in your photo if you're too bright, right? So you need to find a sort of happy medium. You need to evenly light up your scene, your object, or whatever you're trying to track, right? And I know that seems obvious, right? But that's something that we want to make sure that we're within. And as you can see in our sort of our envelope here that we're displaying, is that we have a curve where we want to stay and where we're optimal as far as color goes. Now, when it comes to usability, this is one of the ones that we actually have it pretty easy because we've been using cameras and phones for a long time, and the user immediately knows when they're looking at their phone if there's not enough light in the scene. And usually they'll try to adjust that, right? They'll try to turn on a light or they'll turn on a flash or whatnot. So that's something that we don't have to worry as much about because users are pretty used to it, but just be aware of it. Now with the new devices that Google and Microsoft are helping put in the market, we have the ability to detect range and depth. And with range and depth, it generally uses a technology called time of flight. And what the general gist of it is that there's some kind of an IR emitter or IR light that shines from the device onto an object, and then that infrared light bounces back. There's some variations on it, but it's generally the gist of it. Now, because we're dependent on this reflection of the light getting emitted from the phone or the device, HoloLens, etc., and bounce from something and come back, we're limited on range. And the best way to explain this is that if you ever have a flashlight and you're out camping or whatnot, you're out in a field, and you shine that flashlight right at your feet, you're going to notice that immediately around your feet, you're going to see really bright, intense light. If you were to lift that light up towards the woods or whatnot, you're going to notice that the light gets less bright, and if it's far enough away, you won't even be able to see it. So that's generally how it works with infrared as well, right? There's a limit to the range. And what ends up happening is that if something's too far away, the data becomes so noisy that it doesn't become so useful. So what ends up happening is that the device manufacturers put a hard limit on sort of how far away something can be before it can be seen. And likewise, if something is too close, we also have a difficulty determining where it is. So we have a range, a pretty static range, where if you're within that range, you'll be able to detect objects far away, no problem, but outside of it, you'll have issues. Now, this one here is a little bit trickier to communicate to users from a workflow point of view because it's not so obvious, right? So oftentimes, users will pick up a device, or they'll be wearing a HoloLens, they'll see something far away, and they just assume that the device can see it. So we need to be creative as developers to be able to communicate this properly to users so that way we provide an optimal experience. All right, feature density. Feature density, I'm sure if some of you guys have worked with Vuforia before are familiar with this concept, but I'm just going to go through it really quick. Now, the idea here is that computer vision relies on what we call contrasting features on an object or an image or whatnot so we can properly detect it. So if we have a cube, like we see on the left here, where it's all gray, there's very, very few features. So it's really difficult for us to tell the object apart or the image apart from the rest of its environment. And furthermore, even if we could detect it, then we're going to have a harder time determining its orientation. On the right side, we have something that has way too many features, and what ends up happening is that we have a hard time determining what it is because of all the features. So if you have symmetry in the features, or if you have repeating patterns, it becomes really difficult for computer vision to be able to detect it properly. Ideally, we're looking for something similar to this merge cube here, where there's enough features in it that we can detect it from the rest of the environment, and furthermore, the features are differentiated enough that we can sort of determine its orientation. And you can see this curve here that we're sort of displaying here that describes where we want to be as far as feature density. Now, it is a little bit tricky to the human eye sometimes to determine what is enough features, right? So Vuforia provides some rating systems to help developers with that. Now, that's not the only constraints, of course, right? So we have a lot of other constraints. So our inertial sensors, for instance, are sensitive to how much you're moving. So if you take a phone and start shaking it, you might confuse it a little bit until it sort of resets itself. Reflectivity and transparency is always an issue when it comes to augmented reality, and that's both an issue for optical cameras and infrared sensors. Indoor and outdoors, right? So we have some devices that work amazing indoors and work less amazing outdoors. And then with things like model targets, model geometry also becomes something that we want to be concerned about, so that way we can properly sort of guide the user through the best experience. Now, we are talking about designing for dynamic environments and objects, so we're going to talk a little bit more about smart terrain. So smart terrain is actually what we're calling advanced smart terrain. Is built on technology that Vuforia has been working on for a long time. Now, thanks to Tango that we're currently partnering with for advanced smart terrain, there's no scan phase required. You pick up your device and it immediately starts sort of recognizing your environment and starts detecting what's around you. Now, because of this dynamic nature, we also have this really cool ability where the more you expose your device to, the more information you expose to the device, the more that it knows. And you can see in this little video here where as this drone is moving about, it's detecting the surfaces and it's expanding as you sort of move the phone. Now, what I find particularly cool about smart terrain is that it generates a scene graph. And what that means is as it's exploring the world, seeing the world, it's determining what surfaces there are. So it's looking at vertical surfaces, horizontal surfaces, it's looking for props and objects on top of the surfaces, and it organizes it all in a way that we can sort of traverse through it and look at it as a traditional scene graph, right? So we have this hierarchy. We know which surfaces belong to which other surfaces. We know which props and objects are on top of which surfaces. And that information can be really crucial for making sort of the next-gen experiences. Now, on top of that, once we have this scene graph, we can insert our own content on the scene graph, on these surfaces. So this video here, we're seeing the drone is placing, or the game is placing an ice block on top of a vertical surface. If the same action were to happen on a horizontal surface, it wouldn't do that. So why smart terrain? So the thing here that I want to sort of make sure that I point out is that, so we have this awesome ability where we can now augment the world, right? We have access to surfaces and whatnot, and that's great. We can do that, and I'm sure we're going to see a ton of really interesting experiences from it. But the thing that I'd also like to point out is that even if your objective as an AR developer is not necessarily to augment the world, but to provide a really amazing experience, you may want to consider using smart terrain anyways. And what I mean by that is, let's say you're developing like a tabletop card game, right? For that experience to work out well, you probably need a certain size surface, okay? So let's say you need 0.5 meter square. And that's exactly what you can do with smart terrain. You can sort of query the world for these surfaces, and you can find your half meter square surface and say, okay, well, we can play in this area. And so if you have 3D content, it's not going to spill out, and it's not going to like hang off the edge or anything like that. So think about smart terrain not only in the way that we can augment the world, right? We can sort of put blast marks on walls, and we can make holes on floors, make whatever we want on ceilings, right? We can also use that same technology to improve the usability of existing augmented reality applications. All right, model targets. So with model targets, we have a new developer workflow, and what happens here is that you have your CAD model, or you have some kind of 3D mesh or OBJ or whatnot, and you import it using our tool. Once you import that content, it's just like any other Vuforia application, right? Where we have a database, and that runs on all of our supported platforms, and we run in all the Unity platforms and native and whatnot. So once you sort of create this model database, we can keep reusing it. What I find particularly cool about model targets is the fact that we're no longer really bound by small scale. We can really go big now. We can augment entire cars. I'll show you a quick video of that later. But I think this is particularly cool because I don't know if any of you have ever tried to augment a large object, but it involves printing a lot of paper and then taping it all together and then scanning it with your app. So this is going to make that process a lot easier. And I think it's important to point out is that because of the way that the model target works, we can leverage existing content that we have today. We don't have to modify our objects. We don't have to put in fiduciary markers, right? So if you want to augment a washing machine that was released 10 years ago, you can do that, right? You can add new experiences to devices and objects and whatnot, appliances that have been around in the market for however long, so long as you have the model for it. So I'm going to be showing a quick video from our friends at KnowledgeWorks from Japan that made a quick little prototype of augmenting your car. Let's see if it doesn't crash. So you can see it's pretty tight. They're moving it around. It's pretty tight tracking. All right, cool. So both smart terrain and model targets is going to sort of help us move this forward as far as what we can do with dynamic experiences. So smart terrain, obviously, we can create these experiences and we can author these experiences without knowing where the user is going to be playing these experiences or executing these experiences. And likewise, with model targets, we can leverage existing content. We can leverage existing 3D models and CAD models to improve on that. So I think in both of these cases here, it allows us to be dynamic in the sense where we can create content now that we didn't necessarily think of at the time of when we were creating our original objects. Now, so today I talked a lot about some of the usability issues and some of the challenges that we have in creating AR experiences. And no, we're all still learning. We're all still exploring. And I invite all of you to sort of contribute to this conversation of how we can all make augmented reality better in the future. And I think as it's been mentioned, both smart terrain and model targets are going to be available later this year. And we really cannot wait to see what sort of awesome, amazing content you guys all build with it. And I do want to give a quick shout out to Trigger. So Trigger are the folks that helped us put together the demo that we showed at Vision Summit. It's also going to be available in our booth tomorrow. So if any of you guys want to check out Smart Terrain, we have an awesome demo of it. And in addition to all that, when we release both model targets and Smart Terrain, we're going to include a whole new set of samples that's going to be based on the Mars theme. And just a quick reminder here. Vuforia will be integrated into Unity later this year. I talked to a lot of developers, and some of them are not aware of this, but I think this is really awesome. I mean, what this means is that you can work on Vuforia, you just install Unity, you don't have to install an SDK, you don't have to get a package from the asset store, you can get up and running with it right away. Thank you all so much for coming. Let me know if you guys have any questions. I think we have a system in place. Feel free to reach out to me on Twitter. And awesome, thank you guys so much. I really appreciate you guys coming to my talk. All right, so I'll take the first question here. The OBJ FBX must be uploaded to the Vuforia web. And the answer is no. We're providing a tool for developers. So if you have IP or any kind of sensitive model data, you can process the OBJ FBX or whatever other model with running a tool locally. Can Vuforia consume Creo assembly files? I don't know off the top of my head, but please reach out to me afterwards and I'll get you an answer. So how do large-scale whole room model targets work? It works wonderful. I mean, it's super accurate, and it's going to get better by the time that we release it. So yeah, I'm not exactly sure specifically, but it works really well. We have really robust model target tracking. Are there plans to allow generation of model targets dynamically on the user device at runtime? I'm not sure, but let's talk about it. That sounds like it could be fun. Yeah, I don't think we have that in place right now, but let's talk about it. I'd love to sort of hear your use case, and we can sort of explore that. What's the maximum number of object targets that can be tracked simultaneously? By object targets, I'm assuming model targets or anonymous, I don't know. So we can track lots of objects, and it's going to be partially dependent on your device that you're running on, just because of the CV. We might also have some licensing restrictions as well, but I'd have to double check on that. And as far as model targets, I'm not sure about that either. So this is just released, just announced. So some of these details I'm still personally a little fresh on. But come talk, and then we'll see if we can get you an answer. Is there a confidence level threshold that can be adjusted for the model target detection? So is the question, I'm assuming the question, another anonymous, is that if like we think we see an object, but it's not really it, whether or not we give you a parameter that allows you to determine its sort of confidence. I'm not sure either. I have not personally dug into the API yet, but let's talk more about it. Please reach out to me on Twitter or look for me at the booth tomorrow or Friday, or if you just see me on the floor, please, let's talk. Will CAD importing be supported in HoloLens? I believe the answer is yes. So I believe model targets are going to be available for all of our platforms. HoloLens and Microsoft is an important partner of ours, and we want to continue supporting that. So I believe the answer is yes, but let me confirm. So Sean, please come in and chat with me later. So we previously placed a small high-fidelity model in Vuforia object tracking marker and then tracked full-size object. What are the performance improvements when we look at tracking? So it's hard to say exactly what your tracking performance was, right? So I think I've seen this trick as well, right? Where you take a smaller version and you place it on our scanner and then you scan it. So my guess is that because we know the geometry, we can be a lot more accurate instead of just looking at the contrasting points on the image as we're sort of creating that model. So I can't say exactly like what your performance benefit's going to be. Like it's going to be 95% better, or like that's a little bit hard to sort of gauge. But my guess, just looking at the question, is that you're going to get better tracking, just because the tracking is just that much better. Blend for model targets. So I don't think we're currently supporting blend off of out of the box, but if we're talking about Blender, I'm pretty sure Blender exports to OBJ and other platforms and formats that we support. But if you have a specific use case for Blend that's really critical, come talk to us, and we'll talk a little bit more.
One more question.
All right. Do CAD import models need to be accurately textured, or is it just based on geometry? So the answer to that is just geometry. It's actually one of the things I find really, really amazing about model targets. We care less about the texture, and we try to base as much as we can off of the geometry. And that's what allows us to be very dynamic in the sense where we don't really care what color the object's going to be. We don't care if it's a little bit rusty or a little bit dirty. In general, we should be able to track it. I think that was the last question. Awesome. Thank you guys so much.
Thank you, everyone. Round of applause for Vinny.